us do things. We have very good. Okay, I hope it's okay. Has it come full screen again? Hello?
Yes,
Is it appearing
Yes,
full
yes,
screen
please.
again?
Yes, please.
Very good. Okay, so
Yes, sir.
that is multimedia. Okay, multimedia learning is very, very crucial to learning. But when it is not done very well, it will rather become destructive instead of improving learning. Okay, so there are certain theories, there are certain principles that must be put in place to ensure that the multimedia application that you have designed will go a long way to improve students' learning. Okay, so that is the more reason why we are doing the theoretical foundations of multimedia. Okay, last week we looked at the forms, we looked at is someone hands up? Okay. Because of the full screen, I can't see the raising of hand and so on and so forth. So please draw my attention if you want to talk. Okay.
Doc, is the transcription that stopped? That couldn't happen. The transcription.
Come again.
The sound you heard was from the Gemini, which is used for transcription. It's dropped.
I mean, it's like I can't hear you clearly.
Doc, what I'm saying is that the sound you heard was the transcription, which was supposed to happen.
Okay, okay, the transcription. Okay,
yeah,
all right.
right.
Thank you.
I don't think you can come back with it again.
Oh, okay. Did they start?
It was initializing, but it stopped halfway. I think I don't know if you can help.
I think because of the full screen, let me find out. But do you prefer the transcription?
Very well, Doc.
Pardon me, do you prefer the transcription?
So yeah, we like it.
Pardon me?
Look, at times you don't get it, so I think we can go ahead.
I can.
No, please, we prefer it. People, you
can help
us with it.
Yes, all right, sir. So let me activate the transcription and where are you? Transcription. Hello. Okay, so it's coming. All right, good. So let me quickly do this. Okay, so all right, so that is the background to the whole what do you call it? Theory behind multimedia learning. Okay, so these are the learning objectives that you're going to look at. Things for the next 3 hours or so. We'll look at the cognitive theory of multimedia learning, okay, by Maya. If you've heard about Maya, most of the works in multimedia is done by Maya, okay, Richard Maya. And then we'll also look at the cognitive load theory, okay. And then there's another theory that we'll look at called the dual coding theory. Constructivist theory or constructivism, I wouldn't touch on them. I think we've heard constructivism theory over and over again. The theory that says learning is socially constructed, or children construct their own knowledge through experience. Okay. And then also we'll look at the Gagne's 9 events of instruction. Gagne's 9 events of instruction. And then we'll look at the UDL. UDL, I've decided that I want you to go and read about UDL. Okay. So I wouldn't provide any information on UDL. I want you to read about it. Though I'll put the information on the platform, but for our discussion this morning, we'll not touch on UDL. Okay. So that is it. Now you realize that every picture, every sound, every interaction that we add to our lesson has some kind of influence on your students. Okay, it has influence on them, on the way they think, on the way they remember things, and on the way they learn. Okay, so we don't just have to add pictures, we don't have to just add sound, interaction, and think that, oh, we are just adding them. Okay, it has
Hello, Doc.
influence. Hello.
Please, your slide is not moving.
The slide is
It's static.
that so? I think that is the problem that we have with the full, with the Google Meet. I mean, and it's Shadam Kurao. Okay, so I hope you can see now.
Yes, please. It's on the introduction now.
Yeah, you can see the introduction, right?
Yeah, sure.
Yeah, so that was what I was talking about. Okay, I think I haven't gone far. I'm still on the introduction. So just as I indicated, every picture, every sound, every interaction that you add to your lesson, okay, has some kind of influence on your students in one way or the other. Okay, it has influence on the way they learn, it has influence on the way they remember things, and it has influence on the way they think. Okay, and it's very, 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 very important. You do things and do them right. Okay, but the problem is, how do you know whether what you put there is helping them, okay, or it's entertaining them? Some of the things that we put on our slides, sometimes they don't help students, it's rather entertain them. Okay, it's rather entertain them rather than helping them to learn. The activity that I want us to undertake before we start is to think about this. Okay, think of a time you watched an educational video or use an interactive app. What made it easy or difficult to understand? Let's go back to the memory lane. Let's think about an education video that we watched. Okay, what actually made that video or app, okay, easy to understand or difficult to understand? I hope you understood my question.
Yes, Doc.
Yes. Talk to me, or me, I teach. So I will always invite you to come in and just think. Have you watched any educational video before? Have you watched educational video before?
Okay, Doc, please.
Yes, yes, sir.
Share my idea.
Yeah. Okay.
So, an educational video I've watched would be the recordings of our lessons.
Okay.
And what made it easy for me to watch was links were provided, which led me straight to the material that I needed.
Okay.
And the difficult
come
aspect
again.
was the link.
It does what? It makes it straight.
Links were provided on which when I
Okay.
tap, it takes me straight to the material. I don't need to maneuver my
Okay.
ways through other things. I go straight to the content and I have
Okay.
access to it. The problem I have is with
Okay.
the duration. I feel educational videos shouldn't be so lengthy. But you know, the videos I watched was about 3 hours long, and that was making it
Good.
boring at some point. So that is what I can say.
Okay.
So I think
Okay.
with this one, the designer is supposed to make it more like a summary of the total lesson, which will make it more enjoyable to watch than making it so lengthy, which is the whole period that was spent on the lesson. That is what I can say.
Thank you. So is the length of the video, you found the length of the video problematic, right?
Yes, please. Yes, please.
Sure.
And Doctor, just to add to this.
Yeah.
Yeah, so apart from the length too, there is no editing that is done to it. And so sometimes even pauses, breaks, that will take about 5 minutes, 4 minutes, all of them are included. So when you are watching the video, you have to look at those lapses. So editing in the movie too is very, in attaching the video is also important. When you are attaching video, irrelevant parts that are in the video needs to be scrapped off.
Okay. Thank you. Any educational video that you have watched? Oh, okay. But I gave you a video.
Hello, sir.
Yes.
Hello.
Please come.
So one about it is that you can play it back over and over to understand it well.
Can you come again?
Yes, please. I was saying that you can play it over and over to get the understanding well of what you are learning.
Okay. You can play it over and over again. Okay. It's not just one time. Okay. Something. You can play it. If you are not satisfied, you go over and play it again. And that is beautiful. Thank you.
Sir.
Any other? Yes, sir.
I also watched one on YouTube. It was presented by an Indian.
Okay.
But the way the man was speaking the English, I wasn't able to understand it clearly.
Okay.
So that will also be a problem.
Okay. Yeah. So the accent, you are not familiar with the accent, right?
Yes, sir.
Oh, okay. That's good. That's good. That's very good.
Yes, sir.
Yes, sir.
Okay, so Dr. Amma made us watch series of some, and then one I remember was Articulate 360 or something, and then they were giving us assessments. Even as you complete to a certain level, you are assessed on what you learned before you can continue, or you continue. Yeah, so that's, I think it was beautiful.
Okay. So what made it so easy? What do you think made it so easy, or made it so difficult to understand the content that was being presented?
Sir, is this question to me or something?
Oh yes. I think
I said it was beautiful. I didn't get any problem.
Oh, okay.
No, please let me help.
Yeah. Please come. Yeah. Yeah.
Okay,
please come in.
Doc, please, what made it a bit difficult was that the video moved too fast in some parts.
Too fast then?
Yeah, the designer could have added pauses or short quizzes to help viewers to think about what they just learned before moving on.
Oh, beautiful. Okay, so it was too fast.
Yes.
Okay, thank you. Yes, any other? So all that we are talking about, yes, sir. Let me hear you.
Okay, so I also watch one. We're doing when we're doing computing for mathematics one. We're having one topic. I think events of functions.
Okay.
I monitored the lecture for more than 2 hours. Actually, I didn't get what they are doing because I would say I am naive when it comes to mathematics. So I didn't understand it at all. But after the lecture, I went to YouTube and then I watch it, but I type the topic, I watch a video. The video was 5 minutes, 4 to 4 seconds. I was able to understand everything.
Good.
In less than 6 minutes. So I was surprised, yeah. So the way and manner in which the person was presenting it, the methodology and the illustrations that he was adding to the videos, it made me to just understand perfectly in less than 6 minutes. When I couldn't use 2 hours to understand. Yeah.
That's beautiful. Thank you so much. Okay, so
yes, sir.
Yes, madam. Let's
Sir,
go.
please, my own is about the video you asked us to watch.
Okay.
Yes, on our portal. Yeah, I was enjoying it at a point, but I realized it was moving so fast, much especially with the video that moving ones, and then the subtitles too. They were just going fast. So sometimes I need to pause and then go back and then read again before I could push the button forward. So I realized at a point it was also getting me more confused. Yeah, so the video was moving fast.
Okay.
Yes.
Okay. It should be more slower. The pace should be more slower. Okay. So thank you so much. Thank you for your contribution. And because of this, because of all that you have said, there are certain principles and theories that has been put in place to ensure that you get the best out of multimedia applications. Okay. That is what we are going to look at this afternoon. Okay, so the theories and the principles are theories and principles that has been tested over the years. Okay, and they've been found to be very effective. That is why we want to also look at them. Okay. So each theory that we want to look at, we'll look at the concise explanation of the theory, the proponent of the theory. When we say proponent, the person who developed the theory. We'll look at educational implications, the design implication, and then examples we can use in our teaching or slides. Okay, so that's how we'll look at it. For multimedia, we have looked at it last week. We said multimedia learning is learning that occurs when a learner builds a mental representation from words and pictures. Okay, when they build mental representation from words and pictures. Once we have these two channels working, then we have multimedia. Okay, we can also have multimedia messages, which are presentation consist of words and pictures that are intended to promote learning. So in this presentation, I will give you the events of instruction. Every learning event follows a certain steps. We'll look at that, and that is the steps that you are going to use to develop your multimedia. Okay, so we said multimedia is not about video. That's what I want you to know. That's the more reason why I put this one here. Sometimes when we say multimedia, everybody thinks that, oh, multimedia there and one video, and it's because of what we have in Ghana. Okay, you know, there's a company that they always call themselves Multimedia. Do you know that company? Multimedia Group. Whatever they do, you hear Multimedia Group. You get it. So when we talk about multimedia instruction, it's not always about video. Okay. It refers to teaching and learning material that contains words and images. Okay. Contains words and images. When we talk about images, we can talk about illustrations, we can talk about charts, we can talk about photos, we can talk about animations and videos. Whilst words include spoken or printed text. Okay, so once this is in place, we can have a multimedia, educational multimedia application or multimedia instruction. Okay. The first theory that we will look at is known as the cognitive theory of multimedia learning. Cognitive theory of multimedia learning. Okay. This theory was developed by Richard Meyer. Okay. And it draws from several cognitive theories. When we say cognitive theory, cognitive has to do with the mind. If you've heard about behaviorism, cognitivism, and then constructivism, if you've heard about them, okay. Cognitive theory is based on the things that happen in the mind. Okay, so it draws from theories like the Bedley's model, okay, and then Payaviu's dual coding theory, and then Swaller's theory of cognitive load. Even the third one, we will touch on it. We'll touch on this one, and then even the dual coding, we'll also touch on it. But we are saying that the cognitive theory of multimedia development draws on all these theories. Okay, it draws on all these theories to come up with 8 fundamentals. Okay, so it falls under the large framework of cognitive science and information processing model. Okay, I don't know whether you've heard about this information processing. How many of us know of the information processing model? Have you heard about information processing model? Oh, okay, maybe. Once you want to go into IT in education, some of these things you have to know them. Okay, yeah. So information processing model suggests several information stores, okay, that are governed by processes that convert stimuli to information. Stimuli to information. Okay, so it moves from when you receive the message, it goes into the short-term memory. Have you heard about this? Okay, the working memory and the long-term memory. Have you heard about all these terms?
Yes.
Or this is
Yes, please.
Yes.
You've heard about them. So if you are talking about this, then we are talking about the information processing model. Okay. But I'll touch on them briefly. So what I'm saying is that according to cognitive science, okay, the nature of the brain and how it learns by drawing from research in a number of areas, including psychology, neuroscience, and artificial intelligence, computer science, and what do you call it? Linguistics, philosophy, and then biology. The term cognitive, okay, as used in the cognitive theory of multimedia instruction, refers to perceiving and knowing. Perceiving and knowing. I just want to try to give you some background to that. Perceiving and knowing. Okay. And always cognitive scientists seek to understand mental processes. As I indicated, cognitive theory is always about the changes in the mind, the changes that go on in the mind. So when you present a multimedia application to students, don't think that, oh, it is just about what you are presenting. There are a lot of things that go on in the mind of the student. Okay, so the cognitive scientist seeks to understand mental processes such as perceiving, thinking, remembering. I don't know when you were in the College of Education or Training College. If you remember, we learned all these: perceiving, remembering, forgetfulness. Do you remember? the things that causes forgetfulness.
Yes. I say under psychology and philosophy. Yeah.
Very good. Very good. Okay. So, cognitive scientists try to understand things like perceiving, thinking, remembering, understanding language, and learning. Okay. And these are examples of cognitive scientists that we have listed. And it's very, very important. So just as I indicated, Richard Meyer, 2001 and 2021, he is the proponent of the cognitive theory. Okay. And just as I indicated, this theory indicates or centers on idea that learners attempt to build meaningful connections between words and pictures. Okay. Learners attempt to build meaningful connections between words and pictures, and that they learn more deeply than they could with words or pictures, with words or pictures alone. So this is what Maya was trying to put across. Now it's very, very important to understand that learners form connection between pictures and they learn more deeply, okay, than they could have with words or pictures alone. So when you present only words, only bit like what I'm doing right now, Maya is saying that even what I'm doing is wrong. I should have added some pictures to be for you to understand what I'm teaching. Okay. People learn better from words and pictures combined than from words alone when designed properly. I hope that is clear. People learn better from words and pictures combined than when you teach with only pictures and only words. Okay, so that is what Maya was saying. So this theory has three assumptions. Okay, this theory has three assumptions. The first assumption is the dual channel assumption. The dual channel assumption. And then we have the limited capacity assumption. And then the active processing assumption. Okay, so the CTML, which is the cognitive theory of multimedia learning, has three main assumptions: the dual channel assumption, the limited capacity assumption, and then active processing assumption. We want to take them one by one so that we know what the dual channel assumption says. The dual channel assumption says that working memory has auditory and visual channels based on Badele's theory of working memory. I have a picture of that, so I'll show it to you. Okay, so one, it says that our working memory, in any case, our memory can be divided into 4 chambers, right? Okay, 3 chambers. We have have you seen on the screen? We have the sensory memory, we have the working memory, and then we have the long-term memory. Are you getting it? You have the sensory memory, you have the working memory, and then the long-term memory. You are catching the picture, so that when I go back, you'll be able to relate with what we are saying. I hope that is clear. You can see that on your screen. Hello?
Yes, Doc.
Very good. So now let's go back to what Maya is saying. Okay. So Maya is saying that our working memory has auditory and visual channels. Okay. It has auditory and visual channels. The brain processes information through two systems. That is the visual or pictorial, and then the auditory or the verbal. So these two channels are very, very important. Okay. So that is for dual channel assumption. We assume that our working memory has two channels. Okay. So let us know that. And then the next one, the limited capacity assumption. Let me increase this font a bit so that the limited capacity assumption. The limited capacity assumption is based on the cognitive load. Okay, the cognitive load. So get it clear. We'll talk about cognitive load. Every teacher must know that learners have cognitive load. As you sit here and listen to me, you have cognitive load. Okay, so limited capacity assumption is based on cognitive load theory, and it states that each subsystem of working memory has limited capacity. The working memory has limited capacity. Each channel has limited space in the working memory. Okay, so up to a point when the capacity of the subsystem in the working memory is full, information processing becomes difficult. Okay, so that is the limited capacity. The dual channel has been dealt with, and then the limited capacity is also being dealt with. And then the active processing assumption. The active processing assumption, which is the third assumption. The active processing assumption says that or suggests that people construct knowledge in meaningful ways when they pay attention to relevant material, organize it into a coherent mental structure, and integrate it with their prior knowledge. I hope it's clear. It's not too odious English that you will not understand. So active processing, how we process information. Okay, so that assumption says that people construct knowledge in meaningful way. As you listen to me, you are constructing your own knowledge in a meaningful way by paying attention to relevant materials. What I'm presenting to you, not everything is relevant to you. So you pay attention to the relevant materials and organize it in coherent mental structure. And then integrate it into your previous knowledge, what you know already. Okay, before learning can take place. I hope that is clear. Hope it's clear. So we've dealt with the three assumptions. Good. We've dealt with the three assumptions of the cognitive theory of multimedia learning. Okay. We have the dual channel assumption. We have the limited capacity assumption. And then we have the active processing assumption. So with this assumption in mind, we'll touch on other things. Okay. And then the theory also went ahead to indicate that there are three store structure of memory. Okay, there are three store structure of memory. The first one is the sensory memory. The second one is the working memory. And then the third one is the long-term memory. I think I've touched on this already. Okay, so the sensory memory or the sensory registers or sensory channels is the cognitive structure that permits us to perceive new information. And the working memory, what does it do? The working memory is the cognitive structure in which we consciously process information. We consciously process information. So when your working memory is full, you can't take in information again. Okay. And then your long-term memory is the cognitive structure that stores our knowledge base. It stores our knowledge base. So whatever that you are taking home, you're able to learn after this will be kept in the long-term memory. And then when you push it into your long-term memory, it's not everything that stays there. Okay, the important ones will be left in your long-term memory. Okay, so these are the what do you call it? Three store structure of memory according to the CTML. Okay, and it is found here. That's why I fast forward the whole thing and then for you to see it. Please, I'm teaching, eh? All right, so now let's look at meaningful learning. According to Maya, it says that because of this, meaningful learning can take place when we do these things or when these things take place. So Maya argues that meaningful learning from words and pictures happen when the learner engages in 5 cognitive processes. When the learner engages in 5 cognitive processes. Okay. So when the learner selects relevant words for processing in the verbal working memory. Okay. And then 2, when the learner selects relevant images for processing in visual working memory. And then when the learner organizes selected words into a verbal model. And then he also does the same thing into the images in the pictorial model. And now he integrates the two. He integrates the verbal, the visual, and then learning or meaningful learning will take place. Okay. And that is the picture that he has shown here. Okay. That's the picture that he has shown here. So this is the working memory is very large. Okay. And this is where we store what has been worked on. Okay. And it's whenever we have new information, we'll try to bring what we have, our prior knowledge, prior experience from the working knowledge to bear on the new knowledge that we are processing. Okay. And it's very, very important. So in doing that, Maya tries to define what is meant by no learning, meaningful learning, no learning, and rote learning. Okay, especially at our basic school, we do a lot of rote learning. Maya is saying that meaningful learning is different from rote learning. And there are also at times that we do things in such a way that there will be no learning. Okay. So in doing this, Maya defines learning as a change in knowledge attributable to experience. Okay. If you remember, the behaviorist defines learning as a change in behavior, relative change in behavior, if you remember, change in behavior as a result of what? Experience. Okay. But to the cognitivists or to the cognitive scientists, they are saying that learning is a change in knowledge attributable to experience. Okay. Learning is personal and cannot be directly observed because it happens in the learner's cognitive system. Okay. So as you sit here, behaviorists will tell you, oh, learning is not taking place because you have not demonstrated anything for us to see that there is change in behavior. But the cognitivists will tell you, hey, there is change in behavior, there is change in knowledge. Okay, you have learned because there is change in knowledge based on your experience, what you are experiencing currently. Okay, so once there's a change in the way you think about things, in the way you think about multimedia, once that thinking pattern has changed, it means there is change in there is learning. Learning has taken place. Okay. So he says that it must be inferred through a change in behavior. Okay. It must be inferred in change in behavior, such as performance on task or tests. And he describes meaningful learning as active learning, where learner constructs their own knowledge. So meaningful learning is active learning, where you yourself, you construct your own knowledge. That's what you call meaningful learning. Okay. So we are saying that meaningful learning is demonstrated when a learner can apply what is presented in new situations. And let us have it in mind as we go to our schools to teach. When we teach, we must ensure that the learners are able to apply what we are teaching. And that we teach, and application is zero. Application is zero. Meaningful learning is demonstrated when the learner can apply what is presented in new situation, and students perform better on problem solving, okay, transfer test when they learn with words and pictures. Okay, students perform better on problem solving transfer. Okay, on problem solving transfer tests. Okay, when they learn with words and pictures. Okay, so Maya defines two types of transfer in this. It says we have transfer of learning and problem solving transfer. Transfer of learning and problem solving transfer. And he says that transfer of learning occurs when previous learning affects new learning. This is we have said this. I think you did it in learning theory. You did do learning theories. Hello.
Yes, yes, sir.
Yeah, did you do learning theory? Learning theories. Yeah. So if you did learning theory, I think you did transfer of learning. Do you remember transfer of learning?
Yeah, we understand transfer of learning, sir.
What is transfer of learning? Transfer of learning is there. But do you
So,
remember types of transfer?
yes.
Types of transfer of learning. Anyway, let me. I'll
It was the learning was not meaningful.
Okay, you let me a minute. Give me a minute. I'll be back. Let me read and come back. All right, so I'm back. So we're talking about transfer of learning, right? I hope this is not the first time you are hearing of this term, transfer of learning.
Yes, sir.
Yeah. Transfer of learning. There are three types of transfer of learning. We have the negative transfer, the positive transfer, and then the neutral transfer. Okay. Talking about positive transfer. Positive transfer is when your previous learning, okay, has positive effects on your new learning. Okay, let's say your learning of bicycle, okay, helps you to learn or balance yourself on a motorbike when you want to learn a motorbike. Like, I hope you're getting it. It means that there is a positive transfer. You are getting it. Are you getting it?
Yes, sir.
Yeah.
Yes, sir.
So that is positive transfer. Okay. Now, negative transfer occurs when your new learning, okay, impedes. I hope you understand the word impede.
Yes, sir.
Yes.
Yeah.
Stops you from making progress.
Impedes, yes, impedes the learning of a new task. Okay. When it happens that way, it means that negative transfer has occurred. Any example? Any example of negative transfer of learning?
Hello, sir.
Yes.
Let me try and give this one.
Okay.
Normally, driver says that when you learn driving first, before able to learn how to ride motorbike, you'll be afraid.
Okay.
I don't know whether it works over here. So they said it's good you learn motorbike riding first before you learn how to drive.
Okay. Okay. So that's a good example. If I don't know how to drive a motorbike anyway. So if what you are saying is from experience, then we thank you so much for that example. We can also talk about let's say somebody who drives manual vehicle, eh? And then automatic. Would it impede the driving of automatic vehicle? The person knows how to drive manual vehicle. Would it facilitate it, the learning of the new task, or it will impede it? Yes.
So I think learning automatic, coming to drive manual, that one will impede you.
Okay, that one will impede, eh?
Yes, but with the manual change of using the clutch and then accelerator with the gears, those things. Where some
okay. And then okay, so let's get a negative transfer. Any negative transfer? Yes. And a neutral transfer is when your new learning doesn't have any effect. Your old learning doesn't have any effect on your new learning. Okay. It means that there's a neutral effect or neutral transfer of learning or zero transfer of learning. Okay. So any example of the negative transfer? But you must, yes.
Yeah. Doc, please, someone who is used to typing on the traditional keyboard and switching to a different keyboard layout may slow.
Okay, may slow down.
Yes.
Maybe hitting the keyboard pam. That's because using the other keyboard is more, the computer one is more flexible, whilst this one is more. Okay, so any other example? Okay, so I'll get some few examples for you to understand the difference between. So what Maya is saying is that when we present information, we should ensure that we achieve positive transfer. And then also, there is also another transfer based on multimedia learning called problem-solving transfer, okay, which occurs when previous learning affects the ability to solve new problems. Okay, it's more of positive transfer, but he decided that okay, we'll make it problem-solving transfer. Okay, problem-solving transfer. So when we are teaching, we should aim at problem-solving transfer. Whatever information that we present, or present is such that the student can use the information to solve real-life problems. Okay, real-life problems. Okay, so that is that. So the driving is the language learning is the a student who learned to use Windows PC shortcuts. Okay, try the same thing on Mac. When you go to Mac, the shortcut is different. Okay, the control is not used when you are using Mac. Or a person who is used to driving automatic car struggles when he's driving, what my brother said. And then learning language, an English speaker learning French, sometimes it's difficult. You may pronounce certain things in a way. Okay, so that is what Maya is saying. Okay, that's what Maya is saying. And the educational implication is that we should combine graphics and narration instead of text. Okay, instead of text heavy slides. Okay, avoid irrelevant visuals or background music. Okay, we should use animations with voice explanations. Okay. Now, the next theory is cognitive load theory. Okay, by John Swallow. Cognitive load theory. Okay, so we've dealt with the cognitive theory of multimedia. We'll touch on principles, some principles from there also, so please have it in mind. So the next theory is the cognitive load theory. The cognitive load theory. This theory states that learning depends on managing the limited capacity of working memory. So the working memory has also come here. Okay, the working memory, your working memory, everybody has a working memory. Okay, everyone has a working memory in the mind. But the working memory has limited capacity. And the cognitive load theory states that learning depends on managing your ability to manage, okay, managing the limited capacity of working memory. Good multimedia design reduces unnecessary cognitive load. So 2 words are mentioned here, and I want us to look at them very well. The cognitive load theory and then cognitive load. So what is cognitive load? Okay, when you talk about cognitive load, what does that mean? So have it in mind. We'll look at what is meant by cognitive load, because the theory says that good multimedia design reduces unnecessary cognitive load. Okay. The limited capacity assumptions states, if you remember, limited capacity assumption. Do you remember limited capacity assumption? Limited capacity assumption. Are you there? The cognitive theory of multimedia has 3 assumptions. What are those assumptions? Are you there?
Well, what you say?
Yes. The cognitive theory of multimedia has 3 assumptions. What are the 3 assumptions? Hey.
Hello, sir.
Yes, Auntie.
How the dual limited capacity assumption. Then
Limited capacity
active
assumption.
processing assumption.
Active processing
Yes,
assumption.
active processing assumption.
And then?
And the last one, somebody help.
Okay, somebody help. Who is coming? Somebody to her rescue. Someone to your rescue.
Sir, you said dual channel assumption.
Assumption, very good.
Then please, I'm back.
Okay.
Yes, thank you.
Yeah, you are most welcome. Okay, so it is one of them that we are touching on here. The cognitive load theory by John Sweller, 1998, states that the limited capacity assumption, which we touch on, state that there is a limit to the amount of information that can be processed at a time by the working memory. Okay, the working memory has limitations, so you don't have to think that, oh, you push every information inside. Okay, therefore learning is hindered when cognitive load occurs and working memory capacity is exceeded. Does it make sense? Does it make sense?
Yes, sir.
It makes sense. So how do you understand about this? How do you understand by that?
Yes. So it means that when the working memory gets into its full capacity and you still try to force new information for it to process, it means that that cognitive overload will come, and then it will affect the learning. It will affect the absorption of the new information. If you don't even take time, it will affect even the previous one that has been taken.
Okay. I want another male voice, and I'll take 2 female voices on this, on the statement that I've highlighted red. And then the green one put together. Yes, another male voice. How do you understand by this? I think somebody was saying he didn't understand. So if you can come with your question, we can look at it and then we make progress. But another male voice to explain what is there. Thank you, the first person who did that.
I want to use an illustration.
Okay, very good.
So in our computing, well, let's say you are running a program that requires, let's say, 6 gig of RAM. However, your machine is using, let's say, 4 gig of RAM. What that means is that there's an overload there. And so the application that you are trying to run, they'll be lagging. It will be lagging. It will not be able to run properly. So because it's not able to run properly, if we link it to learning, it means that your learning has been hindered.
Okay, your learning has been hindered. Thank you. Thank you. I think it's a good example to use. Then let me go to the female voices. the treble and then the altos. Yes. The female voices. Can I hear you? Hello, my ladies and ladies.
Hello, Doc.
Yes, let's go.
So it says, when too much information is presented at the same time, the brain becomes overloaded and learning becomes difficult.
Okay.
Yes.
Okay. Very good. Very good. Okay. So you understand it well, eh? Okay. So that is what cognitive overload was talking about. It says learning is hindered. Okay. When cognitive overload occurs. Meanwhile, the word is cognitive load, and we can have cognitive overload. Okay. It means that it is when the working memory's capacity is exceeded. Okay. So that is what we must know. Okay. That's why sometimes I don't even advise learning for 4 hours from 11:30 to 3:30. Anyway, yes, okay, so
hello, sir.
Yes.
Hello, sir.
Yeah, I said yes, my dear. Go ahead.
Hello, sir.
Yes, I can hear you.
Exactly. Can you say too much information can bring confusion?
Exactly. I think you are on point. Too much confusion. When at a time, At a time. Are you getting it? At a time.
Yeah.
At a time. Too much information at a time, just as they are making us do to you guys. Look at the information that we are supposed to give you information for 4 hours. It's not easy. Too much information at a time will cause confusion. Okay, will cause confusion. Yes, my dear.
Sir, what about tiredness?
Tiredness. Yes, tiredness can also set in. Tiredness can set in. When you are tired, there are factors that that hinder meaningful learning. Okay, on the part of the learner. Okay, but here we want to take it from the side of the teacher. I hope you are getting me. Are you getting me?
Yes, sir.
Yeah, so all things being equal, let's say you are not tired, you are not that, all things being equal, if you are teaching, the things that you have to ensure. Okay, so just as we indicated, cognitive load is central to the cognitive load theory. Okay, and we are saying that cognitive load refers to cognitive processing demands placed on a learner in the context of the limitations of working memory. Okay, the cognitive processing demands. As you sit here, there are cognitive processing demands. So the demands are that you understand the concept that I'm teaching. Okay, you understand everything that I'm teaching. Okay, and because of that, we have 3 types of loads. Okay, 3 types of cognitive load. We have the intrinsic, we have the germane, and then the essential processing. Okay, we'll touch on them one by one for you to understand the load. Okay, and it all comes under the cognitive load theory. Okay, what is Intrinsic cognitive load. Intrinsic cognitive load. Are you with me? So with intrinsic load, cognitive load refers to the type of cognitive that is needed, okay? The cognitive processing that is needed to comprehend new information. Okay, that is intrinsic cognitive load. When the information is new, you will need intrinsic cognitive load. Okay. It is also known as essential processing, okay, which relate to essential natural, essential material or information to be learned. Okay, so that is intrinsic cognitive load, and it depends on the nature of the material. The nature of the material. Okay, the nature of the material. So that is the intrinsic cognitive load. Okay. We also have the extraneous cognitive load. Extraneous cognitive load. Okay. So extraneous cognitive load is caused by factors that aren't central to the material to be learned. Okay. Factors that are not central to the materials to be learned. Okay, so whereas intrinsic depends on the type of material, whether the information is new or not, the extraneous cognitive load is caused by factors that are not central. Okay, like what I'm doing, there are some information that are not central to what I'm doing. Maybe the design of my PowerPoint, I've done it such that students are finding it difficult to read. My font size, my what do you call contrast between my background and the text. Okay, all these places some kind of cognitive load, and that kind of cognitive load is called the extraneous cognitive load. Okay, they may include unrelated information. Maybe what I'm teaching, I'm putting in some information that is not important. Okay, some visual element that has no purpose, unnecessary animations. Okay, when you are teaching, your presentation is full of animations, thinking that you are impressing the student. Okay, you are creating a extraneous cognitive load. I hope you understand that.
Yes.
So that is that. Extensive details that are not necessary for particular learning. Okay, extensive details. Allow the student to go and read. Okay, when you do that, it puts a strenuous cognitive load on the student's working memory. Okay, so that is that. And then we have the germane. The germane cognitive load refers to cognitive load that is associated with more difficult learning tasks. Okay, more difficult learning tasks, more complex learning material. Okay, and occurs when learners engage in deep cognitive processing. Okay, so once we have that, it means we have the germane cognitive load. Germane cognitive load. So we have three types of cognitive load. What are they?
Extraneous cognitive.
Extraneous cognitive load. Who can be explained as what?
Intrinsic cognitive load.
Which can be explained as given unnecessary details, which are not
details.
actually. Yes.
related to the material being learned.
Sure.
The design of your presentation, okay, the methods, the way you are presenting it, okay, they are strenuous, okay. And then intrinsic, the intrinsic is which one? The intrinsic is when the information is new, okay. When the information is new, okay, it poses intrinsic cognitive load. And then when the information is more difficult, okay, and complex, and the student engages in deep cognitive processing, it puts or presents germane cognitive load. Okay. Cognitive load enhances learning and results in task resource being devoted to schema acquisition and automation. Okay, so it's very, very important we understand some of these things. And I'm saying that intrinsic cognitive load cannot be manipulated, but a strenuous and germane cognitive load can be manipulated. How do you understand this? Intrinsic cognitive load cannot be manipulated, but a strenuous and germane cognitive load can be manipulated. Yes.
Yeah. So what I understand about this statement is that with the restrictive cognitive load, once the load is coming from the fact that the information is new to the student and the person doesn't have any prior information in relation to that information, there is absolutely nothing you, the teacher,
can do.
Can manipulate that's one. Like you can talk about changing the font size if you is what is bringing about the load. You can change your methodology if you think the method that you are using is what is causing the load. So I think that is how I understand this. Thank you.
Very good. Very good. Yes, Jermaine. Jermaine, can I have a woman to explain the Jermaine? Jermaine?
Yes, sir.
Yeah.
Hello, sir.
Yeah, the Jermaine.
Yeah, so the Jermaine, that one, it's difficult. Probably the teacher may be using, let's say, let me put this in quotes, let's say big English, or the concept, the way it's been framed, full of the grammar, may be very hard for them to comprehend. So in that case, the teacher can decide to bring down the grammar. You can use simple words, maybe role play, sometimes images or videos to back these in order for learners to comprehend them. So that is what I think.
That's right. So thank you for the contributions. I think what you said. So once Jermaine has to do with more complex learning tasks, okay, and then more complex learning materials. We always say that we learn from simple to complex. Okay, so as a teacher, you have to make sure that no matter how difficult the task may be, you can present it in a way that may be less difficult for the student to learn. So that is why we are saying that Jermaine can be manipulated, strenuous can be manipulated. But if it's a new information, it's a new information. Okay, and we encounter new information every day. Okay, so in applying this to our multimedia, we are saying that you have to simplify layouts and instructions of your multimedia. Okay, simplify the layouts and instructions of multimedia applications. Chunk lessons into shorter models. Chunk lessons. Chunking means breaking down. Okay, somebody said the video that he watched, it was too long. Okay, we are saying that chunk means cut or break down lessons into shorter models. Focus learners' attention on key information using highlights or cues. Okay, so you can see that when I get to a certain point, I highlight red. A certain point, I will highlight green for you for emphasis. Okay, so focus learners' attention on key information using highlights. You can use bold, you can use colors, you can use arrows, okay, to point to certain key information in your multimedia application. Every element in multimedia application or multimedia should either clarify or reinforce learning. Never compete with it. Every information or every element in multimedia should either clarify or reinforce learning and never compete it. I hope it's clear. Do you understand this? Do you understand this? Hello?
Hello?
Yeah. I hope we understand the comment here. Hello?
Yes, Doc.
All right. Let me make progress. I thought that I could get what do you call it? Zoom, so that we could do this. Okay. In groups of 10, discuss how cognitive overload could be addressed in educational multimedia. But I'll put it on the platform and I'll put you in groups, okay, for you to discuss it. So please have it in mind. I'll put you in groups, discuss it on the platform, and give me feedback. Okay. The next theory that you want to look at 1:45, we'll have a break and then come back. The next theory is the dual coding theory. The dual coding theory. Yes.
Before you proceed, Mr. Takora, his microphone is on. So if you are listening, Mr. Mustafa, your microphone is on.
Yeah. Mustafa, can you mute your mic? Okay, so thank you so much. The next theory is the dual coding theory. The dual coding theory. Okay. The dual coding theory was proposed by Alan Payavio. Okay, Alan Payavio in 1986. Okay. The dual coding theory. We've done the multimedia coding, multimedia cognitive theory, or the cognitive theory of multimedia. We are looking at dual coding theory. According to the dual coding theory, human cognitive system entails two separate things. Okay, they are related. They are basically a verbal and imagery system. Okay, so the human cognitive system is made up of a verbal and an imagery system. That is what dual coding is about. Both can interact, but can also be activated independently. Okay, so our human mind has two subsystems. Okay, has two subsystems. Usually, verbal information is processed only in verbal subsystem, whereas pictorial information is also processed in the what do you call it? Both subsystem, okay, in both systems. Okay, so let's have it in mind. The underlying assumption of dual code, okay, dual code theory concern basic mental structures and processes. And one, the structures are associative networks of verbal and imaginal representations. And the processes concerned with the development and activation of these structures. Okay, so the assumption is that we have mental structures and mental processes. The structures are associated networks of verbal and imagery representation or imaginal representations. And the processes are the development or the activation of these structures. Okay, so have it in mind. We have two subsystems, verbal and imagery subsystems in our mind. Okay, and it says that information is processed and stored in two distinct systems. That's a verbal system and then the non-verbal system. Okay, so we have text. Whenever you are a student is learning, information is processed in two ways: the verbal system and then the non-verbal system. Okay, so it says that learning is stronger when both systems are activated. Learning is stronger, so have it in mind, so that the teacher that is teaching, myself for example, I should know that what I'm doing right now, I'm activating just one part of the system. You get it? Which part of the system am I activating?
Listen, verbal.
I'm activating the verbal, which means
Yes,
that the
verbal.
non-verbal, which has to do the images and the visuals and the icons, they are gone. The text, I'm doing just the text, the spoken words, but images and visuals and icons missing. Okay, so I will also score 50 over 100. Okay, so we are saying that the educational implication is that of this theory is that combine written or spoken explanations with relevant images. With what? Relevant images. So I think this presentation, I have to update it so that to meet the standard that I'm talking about. Okay. The next thing is that use labeled diagrams and icons to reinforce key concepts. Labeled diagrams and icons to reinforce. I hope this is clear.
Yes, Doc.
It says avoid heavy texts without visuals. Heavy text without visuals. Well, load PowerPoint, if you loaded a PowerPoint with a lot of text, no place to even put a dot. Okay, the multimedia, the dual coding theory says that, hey, students learn better. Learning is stronger. Students learn better or stronger when both systems, that is the verbal system and then the non-verbal system, are activated together. So now I'm activating the verbal system, leaving the non-verbal system. Okay, and it's not a good thing to do. It's not a good thing to do. Okay, so apart from these three theories that we have looked at, I want us to look at another theory or model. Yes.
Please, did he mention videos, or the videos are part of the visuals?
Videos are part of the visuals.
So in case maybe you are doing, let's say you had a presentation, a video form that has maybe a lot of text in the video form, did that one classify under the non-verbal or is part of the verbal?
It's activating both the verbal. The video is full of text.
Yes, please.
The video is full of text. If the video is full of text, then you are like myself. You are here. Are you getting me? You are not activating this one. Are you getting me?
Yes, please.
Yes. So you know, a video, whatever video that we do, we sit down and design it. We have something called script writing. Okay, we write a script. I will treat it and put it on the platform. Script writing. Class rep, kindly remind me that I will do script writing and put it there so that next week you may be doing Camtasia and the rest. So we have to maximize our time by using the LMS. Okay, so if you want to come up with a video, you sit down, you write your script, and you indicate images. Okay, you indicate where the image will be, you indicate where the text will be. Okay, so you need to combine some of these things into, but where you have a video and it's full of text, okay, it makes it dry. Okay, show some images. There are principles when it comes to presenting images and then text. Okay, we'll go through this afternoon for you to see all those principles. We are about 12 multimedia principles proposed by Maya. Okay, we'll go through that. Okay, so I hope it's clear, the answer that I gave you.
Yes, Doc.
Okay. So you are not activating the non-verbal subsystem. You are activating what do you call it? Only the verbal subsystem. Okay. Now, the third thing that I want us to look at, is it the fourth or the third? Is it the fourth or the third? It's third, eh? Third. Okay, good. So the third model or theory that I want us to look at is the Gagné's 9 event of instruction. Robert Gagné, it's a French word. So some people pronounce it Gagné. It's not Gagné. It's Gagné. Robert Gagné. He proposed that every learning or every instruction must go through 9 events. Okay, must go through 9 events. So we call it Gagné's 9 event of instruction. It says every lesson, at every lesson, or every multimedia lesson, okay, multimedia learning lesson must follow this. Okay, that's why we are learning. It must follow this. Okay, so learning occurs best when instruction follows 9 systematic steps, each matching a mental process. Each matching a mental process. Okay, and he says that the first one, I hope you can see from that end. What's the first one? Number 1.
Gain the attention.
Gain the attention of the learners.
Yeah, gain the attention of the learners. Gain the attention of the learners. Number 2.
Inform learners of the
objectives.
Inform learners of the objectives. What kind of objectives are we talking about?
The lesson objectives.
Lesson objectives.
International objectives.
your instructional objectives. Okay. The learning of what you are teaching. Inform learners. Do you see that in my teaching?
Yes, because right from the beginning, you made us to
Yes,
be aware of what we are coming to learn. So that is it.
Good. Good. And then the LMS, when you go to the LMS, do you see something of that sort?
Yes, sir.
Good.
Yes, sir.
Okay. So just as Jesus said, he says, whatever that you see me do, you also go and do it. Hmm?
Amen.
Yes. Amen. Amen. Okay. So that is it. So Gagne says, inform learners of the word, of the objectives. Even before you stimulate recall, you stimulate recall of the word, previous learning. Okay. So the multimedia that you will do, this is what I want to see you. Then number 4 is what?
Present the content.
Present the content. The content, what content are we talking about here?
What you are going to teach.
What you are going to teach for that day. What you are going to teach. And then number 5 says what?
Provide learning guidance.
Provide learning guidance. Provide learning guidance. Number 6.
Elicit performance. That's practice.
Elicit practice. Elicit performance. Elicit performance. And then after the student have performed, what do you have to do?
You provide feedback.
Provide feedback. Provide feedback. Then you have to do what?
Assess the performance.
Assess performance. Okay. You are now going to assess performance. You are now going to assess performance. So it means that every learning cycle must learn with assessment. Every learning cycle. And then number 9 is to do what?
Enhance retention and transfer to the job.
Okay. So you have to enhance retention and transfer to the job. The student must transfer what they have learned in new situations. Okay. So these are the 9 events of instructions suggested by. And in your multimedia development, we must see this. So number 1 says, gain attention of students. Under that, what must you do? Ensure that learners are ready to learn. Okay? They are ready to participate in activities by presenting a stimulus to capture their word, their attention. Okay, and you can do that. You can stimulate their attention with some kind of uncertainty, some kind of surprise. Okay, pose a thought-provoking question, and have students pose questions to be answered by other students. Okay, lead an icebreaker. Do you know icebreaker?
Yes, sir.
You know icebreaker. What is an icebreaker?
Well, it is an activity that the teachers sometimes carry out in the course of the lesson. When the lesson is becoming boring, or when the teacher realizes that the learners are becoming boring. Yeah, sometimes they can also decide to use it at the initial stage of the lesson. If you enter the class and you realize that the students maybe you have the last period for the day, So maybe by that time they are exhausted. So you can bring some kind of games, some kind of play, some kind of stories, just to ginger them up before the lesson will begin. This is just to create readiness for learning.
Okay, I think that is very true. Okay, so icebreakers are very, very important. Start your lessons with icebreakers, the activities to settle students down for the day's work. Okay, it settles them down for the day's work. And then the next one is that you inform students of the learning outcome, okay, or the, what do you call, the objectives of the lesson. Okay, provide objectives before instruction begins. Provide it. Okay, describe the required performance, describe criteria for standard performance, and have students establish criteria for standard performance. Okay, so that is the second one. The third one is to stimulate recall of prior knowledge. Okay, ask students about previous experiences. Okay, ask students about the understanding of previous concepts. Okay, relate previous course information to the current topic. Okay, that is what you have to do. And then the number 4 is the OGA, what you came in to do. Okay, what you came in to do. And present multiple versions of the same content. Present multiple versions of the same content. Use a variety of media to engage students. Incorporate active learning strategies. Okay, so that is presenting the content. And then providing learning guidance. Providing learning guidance. Provide instructional support as needed. Scaffolding that can be removed slowly. Not that once you present the content, and the student, do it and let me see. No, guide them to do it. Okay, guide them to do it. Use examples and non-examples. Okay, examples help students to see what to do, and then the non-examples help students to see what not to do. Okay, what not to do. So that is providing guidance. It's very, very important. Once you teach, you present the content, the next is to provide guidance. And then once you've taken them through the practice, let them practice. Let them practice also. So facilitate student activities. Ask deep learning questions. Ask deep learning questions. Have students collaborate in groups. Provide formative assessment. Provide formative assessment. That is it. And then provide feedback. We have 2 types of feedback. We have the confirmatory feedback and then evaluative feedback. Provide all the 2. Okay, the confirmatory one will inform students that they did what they were supposed to do. Okay, and then evaluative feedback is where the teacher appraises the student of the accuracy of their performance. Okay, so that is the 2 feedbacks that you have to provide: confirmatory and multimedia. When you design a multimedia, I have to see them in it. We also have the remedial feedback. We have the descriptive, and then we have the peer evaluation and self-evaluation. Okay, and then the next one is assess performance. Assess performance. This is where you can use assessment. Now you are going to give them tests, okay, for them to do. Now that you've been able to do this, try your hands on this. Try your hands on this. Okay, so you can implement a variety of assessment methods to provide students with multiple opportunities to demonstrate what they know or to demonstrate proficiency. Okay, and then number 9 is enhance retention and transfer. Okay. Help students to retain more information by providing them with opportunity to connect course concept to potential real life application. Potential real life application. Okay. Avoid isolating course content. Let students have real life examples so that they can apply what they have learned to real life situation. Okay. So that is for what do you call it? Ghanai's 9 event of instruction. Now, I will pause here briefly for 10 minutes. We'll come back at 2 to look at the science of instruction, the 12 multimedia principles, the science of instruction, the 12 multimedia principles. Yes, sir. I think there's a hand up. Yes. Yes, sir.
Please, I wanted to know about the stage where they present the content and then that of the guide learner. So look at the Ghanaians, the principle of this theory. Is it more of electronic way of presenting a lesson, or it can be done physically to like our normal classroom?
Oh, yeah. Yeah, it can be done in your normal classroom. Okay. It can be done through multimedia. It can be done in your normal classroom. You can create your content according to the event of instruction, what it is there. You do it according to the model. Okay, most multimedia, educational multimedia are structured along this line. Okay, but you can also use it face to face. It's very, very effective. Okay, especially the practical based courses. Okay, those of us who teach computing and so on and so forth. After teaching the content, provide guidance. Okay, provide guidance. Try your hands on this. Let's do it. Yes, let's do it. Okay. There are times that the line between the presentation of the content and then the provision of guidance may not be clear. I hope you're getting me. There are times that you may blur the line between the provision of content and then provision of guidance. I hope you're getting me. But have it in mind that when you teach, present the content, let them do. But when you finish, yes, guide them to do some of them. Yes, do it and let me see. Yes, what would you get here? What would you get here? Here will give us this. Where will give us this? Okay, very good. Now then the tests, assessment will come in. Okay, but you provide guidance. And then you allow students to do some of them. And then the homework. Usually, the assessment can be in the form of homework or the assessment exercise in class. I hope you're getting me.
Yes.
Where we can score it. Yeah.
Please, with respect to the practicals.
Yeah.
Could it be part of the content presentation or is part of the guide learner?
Yeah. The practicals, you performing it. It will be presenting the content. You are doing the practicals for them to see. Okay, so you have to do the practicals for them to see. After that, you guide them to also do it. Then you remove the support. I hope you're getting me. So with the guiding performance, your support is there. The first one, you did it for them to see. The guidance, you are there. The support, there's that support. So do it, do it, do it, do it. It's like, I think riding bicycle is where you see it. You ride it, okay? And then after that, come and sit on it. You provide the guidance. After that, you leave the person. You push the person will be sitting on it. You get it. Then probably after that, you give the person some tests. Go around this, go through this, and then once the person gets it right, everything is okay. Then you give the opportunity for transfer. Try it in this situation and let them see how it works, or give them a real life application of what you have taught them. I hope you are getting me.
Okay, thank you.
So when the support is there, you do it for them to see. Then you provide some support. Support doesn't mean that you are doing it. They are doing it. But you give them support. Support, yes, do it. Yes, you understand. Good. So that is the difference. Yes. So ladies and gentlemen, can we come in 10 minutes time to look at?
All right, sir. So that means we'll be back at 2:05.
Yes, in 10 minutes time. So let me pause the video.